And hi, good evening, everyone. Welcome to our new session on Solidity Bootcamp. So, today we have a new instructor. His name is God's Power, and he'll be in charge from now on. So, to avoid further talk, I'll just hand over to our instructor so you can continue. So, over to you, God's Power.
So, hi everybody. My name is Gus Comfort. I'm a developer blockchain just recently. So, I'll bring you through practical version of Solidity. I know you have heard of it from the that you have had. Solidity is a programming language which is used to write smart contract on the Ethereum blockchain. So when I say it's a smart contract used to write on the blockchain, think of it like, shall I say, a storage box. Now, in this storage box, the let's just say you are trying to build a house. You're trying to build a house, and the tools that you want to use is like an equipment. So what you're using to build a house is the language. So for example, I want to build a house. I have pencil, I have pen and paper. These are the equipment I can use to draw my architect of the house, from the drawing of the house, from the implementation of design and everything. You know the tools that I use. So these tools in programming, this what we use are these tools to write beautiful softwares, write smart contracts, write all these apps you are using. Now, Solidity is a programming language which is used to write smart contracts on the Ethereum blockchain. So when I say you can write on the blockchain, think of it like a robot which follows instruction written in code. I know we have been talking the last classes. So what I'll be handling you with is the basic stuffs in Solidity. One, data types and variable. So what do I mean by types and variable? For example, data types, for example, you features that make you unique. Data types are like information that are stored in a variable. What if I want to know what is my name? The data type is a string, which is the variable that that string is holding is gospel. So a data type is what is attached, the meaning to that your name. For example, your name, you spell it as gospel, which is my name, Godspower. That data type of that gospel is called what? String. A string. Now we have others. We have a number. We have one. One is a number. The data type of that number of one is what? A number. That means a number or an integer. An integer, shall I please? I'm sorry. So it's like call an integer. So what do I mean? Solidity has different types of data type, which I'll walk you through. The one is the Boolean data type. Let me type it here. The Boolean data type. So what do we mean by Boolean? A Boolean is like true or false. That is what Boolean means. What you mean by Boolean is, for example, is the light on or off? So programming, it has the data type that tell it, I want to do this or do this. This thing is not is the light on or off. The Boolean statement. It uses true or false. We have another type called the unit. It's like a counting machine. Just like we say one is an, but what it does is it only a positive number. And if we have the unit integer. The integer consists of both positive and positive. Solidity by both unit integer and the integer. That means the unit integer has only positive numbers. You can't use it. And Solidity has smart contracts are very delicate on numbers you use it. Very delicate. I still remember when there was a hack, I think 2017, where smart contract, math, we reached a math overflow, something like that, which was causing a big issue in the Ethereum ecosystem. So numbers are very costly in the smart contract. once deployed, is immutable. A smart contract when deployed is immutable. That means it cannot be changed. So we are being careful of what we write in the smart contract. We have another one, address. Address. Yes. So the address is more of, shall I say, if some of you are doing Web3, an address is the holder of what you're using. A contact in your phone, let's just say like that. For example, you want to call somebody, I'll go to the person's phone number, that's the address. I'm looking for a house, we have an address attached to it. So Ethereum has a smart contract, Ethereum has a address. Recently, Ethereum introduced the Ethereum name domain system, which can be attached to your private key, your smart or this address, which is identification. So address holds where you are, what you are using. It's not just like a contact. For example, this is what an address OS is both a copy of hexadecimal. Address looks like. The next one will be so string in the beginning. In the beginning, what do I mean by string? String are like notepad that store text. Very simple. My name is Gospower. Gospower enclose. Have you seen enclose here? Let's just say Gospower. Gospower enclose with a quotation shows that it's a string. Your name is a string. But if your name has a number and with a quotation mark, it's still a string. For example, this is what I mean. I put 1, 2, 3. It's still a string. As long as I have a quotation in this front, it's a string. We also have characters, we have different, but Solidity deals more with strings. I'll give you another one. We have an array, yes. An array. Solidity also, every programming language has this unique data structure. What I mean by data structure is how we arrange these stuffs. For example, an array is more like array are like a bookshelf. Let's say bookshelf. It's more like a last first out, correct? First out. So it contains bookshelves. For example, we have correct. Is a lasting first out structure. For example, now I have a list of books called book A, B, book C. Book C. Now, this is an array of a list of books. Have you seen? Like you are storing a shelf. It's just your normal. An array is we are using an array in our day-to-day life. When we are arranging our shelf, you want to store in your plate a last in, first out. And that's how an array looks. It holds multiple value. That's what an array means. Now, the next one is the struct. Now, this is the most, I like this one the best. A struct looks like an object. When I mean by object, let me break it down. We have, it holds, for example, I'm a person, God's power. Now, God's power has eyes, God's power must have an age, God's power must have a name, God's power must have a complexion. That is what defines me. A struct looks more like a complete encompass of everybody, of the futures in you. For example, let's just say the struct holds the name. Let's say the name is what? Gospel. And the age is what? 20. That's my normal age. So from here, the struct is telling us a structure of person. A should have what? A name and an age. A person born man, you should have a structure. A name is your unique thing. You must have an age. You must have a that a struct create. So I will be showing you how a simple variable holding these data types are stored. So let me clear this. For example, now we have a contract name. Mhm. Contract name. Hold on. Let's see. Okay, you have to first of all write this. Okay, we have a contract name. What contract name? My contract. Let's use that. Now, now we have a contract name. My contract. I want to write. We have. I told you we have a new integer called what? Public. My number. We said this holding holds what? Positive number. Have you seen? Let me try and put negative. What will it show? There's an error saying type integer minus one is not implicit convertible data type. Meaning data type I'm putting here cannot hold a negative number. Do you understand that? So the boolean we have public. The public is used to when I say public is trying to it's just simple. It's trying to say please this thing be accessible, should be accessible outside the contract. So this means this variable is a boolean variable saying what that my contract is what happy. My contract has a positive integer of core what 42. We also have a string which is also public. My text, my text say what hello. For it to be a string, add you have to add that quotation mark. Can you see it? You have to add that quotation mark. You have to add that quotation marks. So hold on. Yeah. Can you see? I hope you can see my screen to know what is happening. Okay, yes. Let me expand it. So this is how my contract is displaying different different data type, which I'm using to teach you guys. Okay. Hold on. So this one we are going to look at. We are going to be looking at can you hear me? Okay, I think so. I think you can hear me.
Yeah, it seems
Okay,
your
you can hear
network
me.
was good. I can hear you now. You can hear you.
Okay. So if let's say we are trying to do something crazy now, we are trying to after the data types and everything, we are going to be looking at functions. Now, my contract holds this. Like so a function is more like I want an event to occur. It's like pressing a button to perform an action. A function is just like you saying my hand should move if I see money. If I see money. It's very simple. This means that my hand, whenever I see money, my hand should take a move. That's what the function of my hand should do. That's what the function is. So, for example, let me show you how functions are being created in creating a function in Solidity. It's basically simple. For example, we say this is saying hello. Say hello. function, we are going to make it public, and it should be visible. It should return a string. Let's say we want a string which is stored in the memory of the computer. Return hello. So now it's now saying if a button is being saying hello, please return it. I think I'm outside the contract. I should be inside the contract. Oh, what is it? Hold on. Yes. Yes. So we are in a smart contract now. Okay. I'm seeing the error now. So Solidity is strongly typed because I have to put thing. Yes, that's it. I have to put the semicolons for everything. Think so. And press it here. Yes. So it says function state mutility can be restricted to pure. That means I have to put pure to make it pure. Okay, yes. What this my function does is a public function can be outside and it's going to return hello when I deploy it. Let me compile it. Okay, consider. Okay, let's see. I have to add SPA design license. I think I did it. The SPADC license. I think is SPDX something. If I'm correct. Or I'm trying to fix this so they can be deployed. So, oh yes, we have to add an SPDC license on top of it. Yes. So now I was trying to say if you compile it, please apologies for that. Compile, you see, my contract here is public and is making sense. It's compiled. So if I go down, you have to see deploy. Let's look for deploy here. Think, yeah, deploy and run transaction. This way you deploy a smart contract. I'll deploy it now. Now, have you seen my smart contract is deployed here? It's happy to show here. I'm saying call my is being run successfully, which shows true. Number is going to be run, which shows two. X, which shows what? Here, and say hello, what? Here, solidity. I'm saying so. My smart the function telling you whenever I say it should return hello solidity. That what that a function does. It as simple as possible because it's the basic. Now we are going to be talking about control structures. Control structures. So, in order for us to know decisions to make the like a traffic light, green tells you to do what? I don't know what green tells you to do. I don't know what yellow tells you. But a traffic light directs your movement, allows you to make decision. For example, I want to choose. I have three foods on my table. I have three foods on my table. Indomie, spaghetti, and shall I say rice and stew. And I was told if there is no rice and stew, choose Indomie, I will check through the table to check, is there rice and stew? If there's no rice and stew, please choose the next food. A control structure gives you how to make decisions. It guides you how to make decisions. So an if else statement is one of those control structures. A loop also is a control structure because it iterates for every time you are doing something, it tries to iterate it. What I mean by iteration is, please print out one 3 times, say one 3 times, that is iteration. Say one 3 times, that's iteration. So I'm going to show you if else, how to use control structures in Solidity, the if else statement and the oops and the loops. So for the if statement, we are going to do something about even numbers. For example, I created a function. I said a function is like an event that happens whenever you call it. So for example, let's say check even, and now the unit number says what? The number will be coming through here should be what? Positive number. I'm saying, and public. I make it public. What is going to return? And even number is going to return what? In true or false. So I'm trying to check if that number is even or not. It should return a Boolean this in data type. So for example, we say if number module. What do you mean by module? It's trying to check if this is divided by 2. Is the remainder, is there any remainder? We are going to check if the remainder is equals to 0, it is even. I was saying return what? True. Else is what? Return false. So I'll run this to check. Let's say we are going to run it. So Solidity is like more of, I'm thinking it's more of, it collects a higher order language like JavaScript and make it statistically typed, meaning that it must adhere to all instructions. So let's say check sum, check even number 4. Let's check if it's going to run. Mhm. Return, let's check return. Now, so let's just try to deploy it, compile it, and deploy. Let's say deploy it all over again. So let's say we want to check a number 5. False. 5 is not an even number. We want to check it. So true. Have you seen? And down here we have our transaction. The deploying this in, deploying on Remix, we have the environment that we are deploying on. We can deploy on any environment. Can even
Are you there?
connect.
Hello? Okay. I'm sorry, I think we have a little glitch, but we'll be back in the next few seconds. Okay.
So let's say we have a function called what? Loop name. I want to loop my name, and we say a positive number and make public pure returns. It should return what? I think a string, if I'm correct. Let's say we want to return, let's say we want to return numbers. want to return numbers. So let's say for integer I, see if like I is I is less than or equal to what? 5. Yeah, 5. Let's just say like that. Increment it. Then we say, shall I say, how do we return number? Let's say we're using this number. So um, mm, mm, I'm trying to deploy it. Mm-hmm. So we have 3 here. Okay. Returns 4. Mm. Let's just check another method. Let's say to want to look our name. So let's say we have so we are trying to loop function looping a name. So we are going to say function repeat name such that the name is public, pure, and returns a string which is 3 times and store it in the memory. Now we say that I'm giving my string now should repeat 3 times. This string should be 3 times memory names. That means this name should be 3. This string now, the names will be 3 names. So let's loop it now. For a positive number, call what? I is equal to 0. I is less than 3. Let's say because it's going to loop 3 times and return that name 3 times. That's why I said Solidity is more of strict. And say gospel. Then return the name what? Return the name what? Names. So what I'm doing here is repeating my name 3 times. Already tell my function. Name should do what? 3 times in this string. The place where I said store it in a memory. So what I did was I looped names and after I looped through 3 times, each index, we have an array. This would name 0 is equal to what? Space gospel. I'm saying because it's looping 3 times. I say name 1. You still repeat what? Gospel. That's it. Yeah. And it's going to go again. Name, name 2, which is the index 2, which will be the third one. So on a normal, this will be presented as what? God's power, God's power. Please confirm if you can still hear me. Say God's power.
Yes, we can still hear you.
God's power. This is how it will print out. After looping my name, it stores each of the it allocate a certain memory to each of my name. A variable more like when you are storing a variable, it has a small portion. A variable is like a house in your system. So whenever I'm creating a variable, it creates a house for it and say, please store my name there. Three multiple times. Which 3 times? So let's try to run this function. Let's deploy it. We say, let's say, so it's going to deploy my name 3 times. String is returned 3 times. Have you seen? If I wanted to this all the number here, I'll just do what I name. So okay, I'm going to do name because I'm getting the I want to add one to it. Name, loop name. Oh, so because cannot be applied to type string. Let's say because I'm using that. Okay, yes, I want to add the number, like the summation of all numbers. Let's say we want to add a summation of number. It's going to print out, let's say, summation of all numbers, which is this will loop 3 times and will print out. This is what it will do. Name, for example, we have name 0, which is what? Which is going to be what? 0. That's where it's going to start. It's going to add it with what? Add it with 0 plus what? Instance will be 0. The second instance will be what? 0 plus 1. In the next instance, 1 plus 1. Have you seen? No, 1 plus 2 is correct. 1 plus 2. And the instance 3 plus, which is what? That is going to do. Let's just try it. Compile it and deploy. So I cancel it. So let's check repeat name. Okay, it's counting 0, 1, 2. Okay, return. Okay, it's looping. It's not summing, it's looping. It's looping all 1, 2, 3, 4. Okay, yeah. It's going to be looping all the indexes. Yes. It's looping everything. It's not actually adding. I wanted to add. Just say, wow. Let's check names. Hi. Let's deploy it again. Zero zero. Wow. Wow. Let's check. So want to sum is equals to zero. And we're looking through the names. No, my bad. So that's more like Keith. And we're going to return the sums of all number. Sum of all number. Okay, let's say we're returning only one single number. And we're not going to store it in the memory. Okay, we are not going to store this one in the memory too. We are going to clear. We are doing a summation of all numbers. Yes. So we deploy it. So we're going to repeat. Now you see six. It returns six. The summation of all numbers. These functions will get a counter called what? I'm trying to show you how data types are used, and this is used to do a summation. This thing can be pushed to an array. The last in first out scenario. That's this. And I think, please can you hear me? Confirm if you can hear me.
Yes, we can hear you.
Okay, so the next thing I'll be teaching you is memory and structure. You have been seeing how we are using memory and structures in this our code. So a memory is how memory and storage is how data is being stored and accessed. So this is used in the impactation of gas fee. It impacts how we store it in the memory, impacts the gas fee, the performance and data persistence. So if you want to store your variable permanently in what? In your code. You want to store your variable permanently. You use storage to store it. It persists even after a transaction and is very high, and it can be used and saved in the contract. So it's a permanent storage. So after transaction, it does not remove. It is still saved in the in the storage. So the memory is more of a temporary data versatile. It's exists only for execution. You only to perform a function execution, but in a storage, it works even after the transaction. It is cheap and it is used for function but does not persist. So it is used in function, and why this one is used everywhere. So the key difference about storage and memory, uh, in the blockchain, storage is permanent, is immutable. So, but the memory is used in function and it cannot. It's used in execution and it's temporary. It's high cost because it's being stored on the blockchain, and is the memory is very cheaper. Uh, it persists. The storage only persists when the function end. As soon as the functions end, that's when it stop working. But in It stays. Sorry, the storage stays even when the function ends. It is still recorded, but in the memory it is not recorded. It disappears along with the function. The uses it is used in storing permanently, and in memory is used in function variable, while in storage it is used in naming variables, state variables. So you use storage when you want to make the data persistence in the transaction, user balancing, contrast state, and you use memory when you want it to be what, on a function only to save gas fee. So it is mandatory. I think in optimization you go for memory, which is best. I think I'm done for today. Next we'll be handling more on topics like life cycle. I've touched state variable. We were looking at constructor and fallback functions, event and logging, and basic error handling. And then we deploy a smart contract. We have already deployed one of the deploy smart contract. I've shown you how to deploy a smart contract, which was great having you all. My name is Gospar. I'm a front-end developer and a blockchain developer. Thank you.
All right, thank you very much, Gospel. That was a great session. I feel like the practical session was just following up with everything. Um, Thank you very much for that. Uh, I'm
Okay.
looking forward
Thank you.
to the next sessions. I want to learn more. It's like I'm now taking interest in this stuff.
It's
Yeah.
not an issue. Thank
All
you.
right. All right. So that marks the end of our session today. So we'll be seeing you guys on Saturday. See you guys again. Thank you for joining us. Bye and have a nice night. Take care. Bye, Gustav.